Good morning, all of you. Can you hear me, Mukti? Can you hear me?
Yes, ma'am.
Okay.
Yes, ma'am.
Yes, ma'am.
Okay. So all are already in. So we were on off-bow principle. What is off-bow principle? Kangana, what is off-bow principle? Please tell me. Mukti Patodi, what is off-bow principle?
Sorry?
What is off-bow principle? Like this we did. Off-bow principle. Palaksh. What is off-bow principle?
The electron will be filled in the subshell in which the energy is less.
Yes. Orbitals are filled in the increasing order of their energies. Orbitals are filled in the increasing order of their energies. Mukti, please tell me, what is off-bow principle?
Orbitals are filled in the increasing order of the energy.
Orbitals are filled in the increasing order of their energies. Okay. Next rule, Hund's rule of maximum multiplicity. HUNDS. Hund's rule of Hund's rule of maximum multiplicity. Hund's rule of maximum multiplicity.
देख लो
पागल एकदम फोन के बच्चे ही हैं।
Right on. It states that pairing does not occur. Pairing, P-A-I-R-I-N-G, pairing does not occur until the orbitals of same subshell are singly occupied. Until the orbitals of same subshell are singly occupied. For example, say degenerate orbitals of 2p, that is 2px, 2py and 2pz. 2px, 2py and 2pz. Suppose the first electron is coming here. The next electron will not pair. Next electron will not pair. It will go to the next orbital like this. And next until the orbitals of same subshell, 2p subshell, or until the degenerate orbitals. Degenerate orbitals means orbitals are having same energy. 2px is having same energy as that of 2py, which is having same energy as that of 2pz. So until the orbitals of same subshell or until the degenerate orbitals are singly occupied. So singly occupied. Now the next electron comes and pairs. Pairing. So this is Hund's rule of maximum multiplicity. If there are two or more orbitals of same energy, orbitals of same energy means they are of the same subshell. Until all the orbitals of same energy are singly occupied, pairing does not take place. So pairing does not take place until the orbitals of same subshell or until all the degenerate orbitals are singly occupied. That is Hund's rule of maximum multiplicity. If it is 3D, in 3D there are 5d orbitals. In D there are 5d orbitals. What are they? dxy, dyz, dxz, dx square minus y square, dz square. So I am going to draw 5 degenerate orbitals. Degenerate orbitals means orbitals of same energy. So 1, 2, 3, 4, 5. So suppose one electron comes here. The next electron will not pair. It will go to the next, then next, then next, then next. Now pairing starts. Once all get one electron, then pairing starts. Pairing. So this happens from 21 to 30. 21 to 30. 21, 3D1. 22, 3D2. 21, 3D1, 22, 3D2, forest 2. Forest 2 already filled. Forest 2 is having lower energy than 3D. So forest will be filled first. How can you check the energy which is having higher energy and lower energy? That is by N plus L value. N plus L value. N, that is You can consider 3D and 4s. 3D and 4s. 3, this is n value. Here 4, that is the n value. So n plus L value, that is 3 plus 2, that is 5. D, L value of D is 2. I told you, like this you should consider 2. Okay. So 3 plus 2, 5. But here 4 plus S, I told you, consider it as a circle. Right? So 4S, that is 0, circle 0, that is equal to 4. So you can find out the energy which is having lower energy, which is having higher energy by adding its n plus L value. If n plus L value is less, see 4S, first electron will be filled there. First electron will be filled there. 4S. Then only it will be coming to 3D because 3D is having higher energy than 4S. Which is having higher energy, which is having lower energy? You check its n plus L value. N plus L value lower means lower energy. So 4S is having lower energy than 3D. In the previous class, we already said 3D is having higher energy. In that snake-like diagram, first 4S is getting filled, after that only 3D is getting filled. Okay, so 1S, 2S, 2P, that snake-like diagram. Okay, so 3D 1, this is 3D 1, 3D 2, 3D 3. For 3D 4, I said to attain half filled stability, if it gets 3D 5, 3D 10 is the full filled. 3D 5 means half filled. Half filled and completely filled orbitals are more stable than the other configurations. So to get here 3D 5, one electron will be taken from there. So I'll be writing 1 here and only 1 there. So here it is 3D 5, 4s1. Like this. Then 3D chromium is over. So scandium, titanium, vanadium, chromium. For manganese, it is like this only. Manganese like this. Manganese. For iron, now iron comes. For iron, pairing starts. 26, 3D6. 27, 3D7. 28, 3D8. 29, 29, it is like this, but if it gets one more electron, it will attain full filled stability, completely filled stability. So one from here will be taken here and there will only one. This is for 29. 29 is copper. Copper. So exceptions are there in 24 chromium and 29 copper. 24 chromium and 29 copper. Okay. So that's about Hund's rule of maximum multiplicity. Next rule. One more rule is there. That is Pauli's exclusion principle. Pauli's exclusion principle. So three rules are there for filling this configuration, electronic configuration. One is Aufbau principle, that means building up. Aufbau means building up. So Aufbau principle states that orbitals are filled in the increasing order of their energy, in the order of their increasing energy. Okay, So here in Pauli's exclusion principle, no two electrons in an atom can have all the four quantum numbers same. At least one quantum number will be different. Means exclusively for one electron's address is not the address of the other electron. Suppose one letter is coming to your house. For example, to Mukti Patodi, one letter is coming. Nowadays, no letters are coming. All are emails. You think one postman is bringing one letter to Mukti Patodi. Now, there is only one Mukti Patodi with her home address in this world. District, same. Others, Mukti's Mukti's siblings are brother or sister are having same district name, same colony name, same road, same house, but the name is different. Mukti's name is not not her brothers or her sisters. So that letter goes to that particular person. Other quantum numbers may be same, but one quantum number will be different. Suppose Mukti and her neighbor, then the house name, house number different. Suppose one more Mukti is there in the neighbor's house, but their house numbers are different. District same, colony same, road same, but the house is different, though the names are same. So every individual has got one address. Every individual has got one address. Similarly, every electron has got exclusively its own quantum numbers. Some quantum numbers may be same with the others, but one quantum number will be different, which shows that means the address of that electron is particularly for that particular electron, exclusively for that electron, only for that electron. So Pauli's exclusion principle states that, write down, Pauli's exclusion principle states that no two electrons in an atom, no two TWO, no two electrons in an atom can have all the four quantum numbers same. All the four FOUR, all the four quantum numbers same. At least one quantum number will be different. At least one quantum number will be different. One quantum number will be different. Now you see, hydrogen nucleus, one shell. Hydrogen nucleus, one shell. One shell. It can accommodate two electrons. One is orbital. This first n is equal to 1. N is equal to 1. This is 1s orbital. So electron number 1 and electron number 2. Let's see the address of electron number 1 and electron number 2. Electron number 1 and electron number 2. N is equal to 1 for electron number 1. N is equal to 1 for electron number 2 also. L value, when n is equal to 1, L can have one value, that is 0 to n minus 1, that is 0. Here also 0, that is also same. M value, if L is 0, then M can have 2L plus 1 value, that is 2 into 0 plus 1, that is 1 value. What is that 1 value? That is ranging from minus 0 through 0 plus 0, that means 0. Similarly, here also 0. But S value, S can have, this is in one orbital electron, only 2 electrons are there. Those 2 electrons will be in one orbital S value. One will be having plus half and S value, other will be having minus half. See, at least one quantum number will be different. That means address of this electron is different from the address of that. Shell is same, orbit is same, energy level is same. Now, subsidiary quantum number or azimuthal quantum number, these are same. Then magnetic quantum number, these, that is also same, but spin quantum number is different. Spin quantum number is different. So exclusively, these 4 quantum numbers exclusively for one electron. At least one quantum number will be different. That's about Pauli's exclusion principle. Or you consider helium. Okay, this is helium. Helium with 2 electrons. This is helium with 2 electrons. So next we'll be going to lithium. Hydrogen has got only 1 electron. Hydrogen has got only 1 electron. Helium 2 electrons. Next, now we are going to lithium. For lithium, there are 3 electrons. So I am going to draw for lithium. So one more electron is there. So electron number 1, electron number 2, this is electron number 3. Let's see electron number 1 and electron number 3. So this is electron number 3. Electron number 3. Electron number 1 we have already written. That is n is equal to 1, L is equal to 0, M is equal to 0, S is equal to plus half. Alright. Electron number 3, for that n is equal to, which is n. See, this is electron number 3. N is equal to 2. See, n is that second shell. N is equal to 2. So there itself it got changed different. N is equal to 2. Right? N is equal to 2. L can have 2 values ranging from 0 to n minus 1. So 0 and 1. Okay, L is equal to 0. So here n itself got changed. So you don't have to go for the other because one quantum number is already different. So Pauli's exclusion principle states that no 2 electrons in an atom can have all the 4 quantum numbers same. At least one quantum number is different. So first we check for helium. Hydrogen has got only 1 electron. In helium, there are 2 electrons. So you can compare the address of these 2 electrons. Hydrogen you don't have to compare because it has got only 1 electron. Okay. Now, so you have seen orbits and orbitals. Now you write the differences between orbit and orbitals. Differences between orbit and orbital. 2 columns you drew. Orbit and orbit. Orbit and orbital. Orbit. Well-defined circular path. Well-defined circular path around the nucleus. Around the nucleus in which electron revolves. Well-defined circular path around the nucleus in which electron can revolve. Yeah, electron revolves. that side, a three-dimensional space, a three-dimensional space around the nucleus, around the nucleus, where probability of finding electron is maximum. Probability of finding electron is maximum. Number 2, the concept is not in accordance with, the concept is not in accordance with wave character of electron. The concept is not in accordance with the wave character of electron and uncertainty principle. Uncertainty principle. That's it. Concept is in accordance with wave character of electron and uncertainty principle. First case में not, second case में in. Concept is in accordance with, concept is in accordance with wave character of electrons and uncertainty principle. Concept is in accordance with wave character of electron and uncertainty principle. Number 3, circular like. Circular like. Orbits are circular like. That's right. Different shapes like spherical, different shapes like spherical, dumbbell, etc. This side, 2n square is the maximum number of electrons. 2n square is the maximum number of electrons in any orbit. In orbital, an orbital can accommodate maximum 2 electrons. Two electrons. 2 electrons. 2 electrons. And left hand side do not have directional characteristics. Do not have directional characteristics. That side have directional characteristics. Have